Hello viewers and my dear students. Welcome to session 2 on CNC thread cutting video tutorial using EdgeCAM. This is in fact problem 3, demo on use of CAM software, that is EdgeCAM, for generation of G&M codes for a turning profile involving curves, grooves and threads. Now, as I told you just now, this is session 2. In session 1, we have completed the problem. Almost 50%, 55% of the problem is already completed, and the problem is this. As you know, the problem was this design and all that is over, and even in the manufacturing also, we have come to the manufacturing stage also, where we already fixed for fixing, that is facing of this. We've already done rough turning of this, we already done finish turning of this, and rough grooving of this, and finish grooving of this also has been done. Only thing is left out is this thread cutting has to be done. That I'll be showing it to you now. Okay, now as you see here, that is rotating the middle button. You can enlarge or reduce. Now I have reduced. See here. Now as you know here, the facing has been done. You just see. Facing has been done. You can see the highlighted versions. Okay. Facing has been done. Then rough turning has been done. And then finish turning has been done. Finish turning, you see here, finish turning only on this profile. Okay, only here the finish turning has been done only on this, and then grooving, rough grooving has been done, and finish grooving also has been done. Okay, and that means if most of them have been completed, we have one more thing to do, that is the thread cutting portion. Okay, now we go for this tooling. Thread you go, find you go. Okay, this you take 1.25 extra GC 1020. You take, select, and this you be careful. Nose radius you compulsorily give some 2 mm, and this reach you give 5 mm. Okay, all other things you can maintain constant. This you have it same. Okay, reach 5, nose radius 2 you take. Okay. Now this is the tool you get. Okay, and then and turn cycles you go, and thread you go. Thread, if you go here, speed, let us say I'll fix it at 500, because the thread cutting you don't need a very high speed and all that. This 500 will retain, and pitch is 5 mm, because they are given in the problem pitch is 5, and then don't change any other thing. Then depth is 3.06 they have given. Okay, then what you have to do is cut increment. That means totally 3.06. Okay, once you do, the 3.06 mm will be the depth here as well as here. Okay, it is actually total depth is 3.06 into 2. That is 3.06 mm is the depth here. Okay, and even here 3.06 in that way. But here I can give number of 10 passes as 10 and all that. Otherwise also, cut increment, let us say, every time I'll increase by 0.5. Final increment, 0.1. Start depth, also 0.1. In that way, whatever you give, you get it. Cut increment, everything, every time, first final increment, start depth will be 0.1. Final increment, you can give very slow, small also, 0.01 also. For getting better finish, and cut increment every time 0.5, 0.5 in that way. Final increment also I just given 0.1. Start depth also I given 0.1 till it becomes 3.06. It will be doing. Okay. Now this I'll make it the number of passes, because these things itself will control. 0.5 is the cut increment. Every time it cuts by 0.5, and final increment is 0.1. Start depth is 0.1. In that way I've done till the total depth is 3.06. It automatically gets adjusted. Okay, just say okay, and take this carefully here. This threading has to be done on this 52 mm diameter. Okay, just do it here. Okay, now you see 3.06, this has come. 3.06 is the thing here. Okay, this 3.06 is the thing what you got. Now you see here, if you want any changes, now you double click on this thread cutting. Okay, 500 depth of cut. 3.06, you can make anything, any changes and all that you can do here. Okay, And in the same way, if you want any changes here also, you see here, included angle 60 degree I've done. Let us say I'll make it 20 degree. Okay, 20 degree. You see here, now it is 60 degree. I'll make it 20 degree. You can make 20 degree here. Okay, that's why in the same way, depending on the requirement, you can change it. I've told you how to make the changes and all that. Now, all have been over. See here, so many operations we have done. Okay, roughing tool, rough turning, sorry, rough turning, that is facing. Okay, rough turning, this is the tool path. Okay, so many times the tool will come like this, style like this, in that way. Every time it comes, say since cut increment is 1 mm, diametrical reduction will be 2 mm. These are all the tool paths. Then turning tool, finish turning, you see here, finish turning will be on this. Okay, then grooving tool, rough grooving, finish grooving. Okay, rough grooving means it will that is it will have an allowance of 0.5 on the sides, 0.5 on the base also. That means if it is actually 42 mm, it would have been 41 mm, and during finish 0.5 will be the depth of cut, so that it becomes 42. Okay, in that way, threading also, thread turning and all that, everything, all operation, whatever is required for this problem has been done. Okay, once you do this, you just have to simulate batch. Okay, simulate batch, as I told you, it takes a little time because of the number of operations and all that. Just have to wait. Okay. See here, as you know, all operations are here, and wherever you want, you can go double click and you can make changes. Okay. Now you have up to thread cutting we have done. Okay. You have here roughing and OD turning, rough OD turning, finish OD turning, rough that is rough grooving, finish grooving, and thread cutting. All have been there. Now it is this. Now keeping the right button pressed, and if you move, you can move it to any isometric position. Okay, that is you can tilt this. Okay, you can tilt this. Now speed control, you make it minimum. Okay, and you can start simulation. Okay, if you want to increase speed, you can slightly increase the speed. Now it is cutting, you are concentrating on the facing. Now once it is facing is done, as you know, it does, and it will remove, it will retain 0.5. It will retain 0.5 on this surface, that is on the face. Okay. You are controlling the speed control and all that. This is a 3D simulation. Now as you see here, this will be 100, but actually after rough cutting it will be 101. I'll just tell you now. It is, now you see here, this is 100 actually. This will be actually 101 now. During finishing, with the depth of a cut of 0.5, he'll remove that 1 mm, because 0.5 depth of cut means diametrically it reduces by 1 mm. Okay, this is 100. Now in the same way, here it will be 52. Here it will be 52, but after roughing it will be 53. During finishing, that 1 mm will be removed with the depth of cut of 0.5. Okay, you see here in the output, rough turning is over. Now OD rough turning is going on. That's what it is telling here. In the output you just see rough turning is over, that is facing. Rough turning and OD is being done. Okay, this is a 3D simulation, and in the examination and all that, the examiner will ask this 3D simulation you have to show, and also 2D simulation. I'll tell you that is very important, because you know, see here beautifully it is doing the finish turning and then finish grooving, and thread cutting also it is doing. Okay, now it is doing, as you know, as I told you earlier, if you want to redo, if you do this, again you can, if you do this, if you play this button, again you can show the simulation. If you do this, whatever you got earlier, you can see this. Okay, if you do this, okay, you will, if you click on this button, you will get the entire raw material, and using this, the required profile can be obtained. And if you press this, the simulation again starts. Okay, this is one portion of this. This is 3D simulation which has been asked, which you have done. Now what you do is, now you go here. Okay, simulation mode. Simulation mode, if you go, simulation speed, let us say you take 30. Let's say okay. See here, this you be careful and go for tracking also here. Now you see here, and Z, you can see here, now it is cutting on the extra 5 mm, no, it is cutting. Okay, once it becomes 0.5 it changes. Now you see here, 0.5 is that, it changes. Now it goes on OD. You see here, the tool path has been generated. Every time it reduces by 2 mm. Since cut increment is 1, it reduces by 2 mm. You can see X here, 109, 107, 105 in that way. But once it becomes 101, it changes. You see here, carefully you keep looking at that. It becomes 101 at one stage. See here, 101. Okay, now it changes to this. Then it goes on doing, and here it is 52. You keep observing X now. Once it becomes 53, it stops on, because only in the during finish turning that 1 mm allowance is that is 1 mm allowance on X and Z. Okay, that 0.5 no, totally 1 mm is there. That is this will be 101. This will be 53. That will be removed with a depth of cut of 0.5. Okay, now you see here X you keep observing. Once it becomes 53, it stops. 60.85. See here, 53, it stops. Now it is finished cutting, you see here, beautifully 100 minus 120, everything is done. Now roughing is over, then finishing is also over. Now you have this, thread cutting is also over. Okay, now it has done in all respect. Now the problem is over. This is what you are expected to show to the examiner. And if you make the simulation slow, everything you can see. Clearly this will be after rough turning, it will be clearly 101. After rough turning, this will be clearly 51. Okay, and you can clearly see this 0.5 allowance after rough facing. And during finished turning, this 0.5 will be removed, 53 will be changed to 52, and then 101 will be changed to 100. Did you follow? This 0.5 will be removed, then 53 will be here, that 53 will be changed to 52. Actually that is what required. Okay, and at the same time this is 100 and 101 will be there, and 101 will be changed to 100. In that way you are getting exactly the profile what you wanted. Then you just see here, you save this file, save as, okay, save as, okay, in the name of, let us say Gurdat thread cutting. I have just done already, Gurdat thread cutting.ppf. You save it. Now once you save this, then the important thing, generate code, is very important thing. You just say okay. Generate code is the generation of G&M codes for the entire thing. The thing what I'm telling you here is, for any profile, we are not doing manual part programming. We are using a CAM software to generate G&M codes, which we directly load it to CNC machine, and we'll get the component done. Okay. Now you see here, whatever is the default value, I'll just take it. Okay. Then you are getting the G&M codes. This is the G&M codes. Carefully follow. This is the G&M codes. What you have got, what this entire thing, so many lines it has here, up to 1400 and 1570. That means almost 157 lines that it has written. This is the code path. That is X and Z. X is on the diameter, Z is on the axis. The tool will move as per the X and Z. And if the tool moves as per X and Z here, your profile is obtained. This is the way. This G&M codes, you are directly copying it and loading it into CNC machine to get the required profile. This is what is expected of you. This is a very important thing. Okay, now we have come to the end of session 2. Thank you very much for watching. Thanks friend. Thank you.